Welcome to Luvitex Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
So, let's talk about a piece of technology that's an absolute powerhouse, literally moving our world. But it's so common, so fundamental, that you probably don't even see it anymore. We're talking about the simple, brilliant pulley. Okay, let's dive right in. What you're looking at here is probably a familiar sight if you've ever been in a factory or a workshop. A belt drive. This thing is the workhorse of modern industry, right? It's transferring power, making things spin, just getting the job done. But the genius behind this is way, way older than you might think. But here's the wild part. The core idea you're seeing in action right there, it's not a product of the Industrial Revolution. No, its roots go back almost 4,000 years to the very beginning of engineering. And that's what's so incredible, isn't it? This super simple machine has not only survived for millennia, but it is still absolutely essential in, well, in everything from massive construction cranes to precision CNC machines. So how? How did this ancient invention become so vital to our modern world? Well, to really get why it's lasted so long, we have to go way, way back. We need to see just how deep its roots are in human ingenuity. So the earliest evidence we have takes us to ancient Egypt and Mesopotamia. Back then, they were used for a really basic but totally critical task, lifting heavy stuff like stones and water. By the time the Roman Empire rolled around, thinkers like Hero of Alexandria had made it official, classifying it as one of the 6 fundamental simple machines that basically make civilization possible. But the real mic drop moment, that came from the legend himself, Archimedes. Plutarch tells this amazing story where Archimedes sets up a system of pulleys and then, all by himself, pulls a huge, fully loaded ship right onto the shore. I mean, can you imagine seeing that? It must have looked like actual magic. So, how did he do that? Well, that magic has a name, and it's all about physics. Let's break down what makes the pulley so incredibly powerful. It's all about something called mechanical advantage. And put simply, it's just how much a machine multiplies your own effort. With pulleys, the secret is beautiful in its simplicity. The more sections of rope you have actually supporting the load, the easier it is to lift. It's that simple. Just look at the difference here. On the left, you've got a single, fixed pulley. All it really does is change the direction you're pulling, which is helpful, but it doesn't make the load any lighter. But look at the right. Just by adding one more pulley, we now have 2 ropes holding the weight up. And this is the secret sauce right here. It's all about the trade-off. With that second pulley, bam, you suddenly only need half the force to lift the same weight. It literally feels twice as light. But there's always a catch, isn't there? The trade-off is that you have to pull twice as much rope to lift it the same height. You trade distance for force. It's a brilliant, brilliant exchange. So for literally thousands of years, pulleys were all about one thing, lifting. But then the Industrial Revolution came along and completely changed the game. It wasn't just about lifting things anymore, it was about moving them, driving them. This right here was the huge leap forward. By connecting 2 pulleys with a belt, engineers could take the power from one single engine and spread it out to a whole bunch of machines all across a factory floor. This is the birth of the belt drive, and it basically powered the entire Industrial Revolution. Of course, technology never stands still. As machines got more complex and their needs became more specific, the belts themselves had to evolve. And this led to 2 main designs that are really good at very different things. And this table breaks it down perfectly. You've got your flat belts, the original design. They are super efficient and fantastic for sending power over long distances. But then you have V-belts. Their trapezoidal shape is all about packing a punch in a small space, using a wedging action that dramatically cuts down on any slipping. And here's a close-up of that V-belt. The genius is all in that shape. You see, it doesn't just sit on the pulley, it wedges itself into the groove. This creates way more friction than a flat belt ever could, which means it can transmit much more torque without slipping. That's why you find them in things like car engines and heavy machinery. Okay, so let's fast forward to today. In our world of high-speed robotics, precision manufacturing, and CNC machines, it's not just about brute force anymore. Now, it's all about incredible precision, speed, and rock-solid reliability. And that means the materials we use have gotten incredibly specialized. For high-speed robotics, where every single gram counts, you go with lightweight aluminum.
For the tough, industrial transmissions that power our factories, you need hardened steel. For huge, heavy-duty jobs that generate a ton of heat, you turn to cast iron. And we even use specialized plastics in everything from our office printers to medical equipment.
But you can have the most advanced, perfect material in the world, and it all means nothing if one tiny, crucial detail is off. And that detail is alignment. Even the slightest misalignment, whether it's offset or at an angle, is a total disaster. It causes belts to shred themselves, it creates crazy vibrations and noise, and it can waste up to 15% of a machine's energy. So what's the modern fix for this age-old problem? Lasers, of course. How cool is that? Tools like this shoot a laser beam from one pulley to the other, letting a single technician get in near-perfect alignment in just a few minutes. This saves a ton of money on downtime, makes the equipment last way longer, and saves a whole lot of energy. So when you step back and you look at the whole picture, the journey of the pulley is, well, it's just incredible. It truly is one of the great unsung heroes of engineering. I mean, think about it. It started as this simple tool that let people do the impossible. Then it became the beating heart of the Industrial Revolution. And now it's a high-precision component in some of our most advanced technology. It's just constantly evolved to meet the needs of the time. It's a perfect reminder that sometimes the simplest ideas are the most powerful and the most enduring. So the next time you see a crane or an elevator or even the engine in a car, ask yourself, are you just seeing a machine? Or are you seeing an ancient genius that's still hard at work all around us?
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.